Cool, I think I'm streaming, twitch.tv, let's see. I'm not offline. And okay, well, that is the video. Let's look at that. Okay, let's put it on Twitter. Okay. And we're streaming. Okay, and let me get to the chat. Where's the chat? There's the chat. Am I live? Yeah. Great, I'm live. Okay, so I don't have any viewers, so I'm just gonna keep working until I get viewers. Sounds good. Well, even though I don't have viewers, wait, no, I do have viewers. Hi, viewers. Okay, great. So this is a an experimental version of Drippie. Drippie is the system that Optimism uses to automate stuff on Ethereum. And yeah, so I discovered Weiroll, or I guess I was aware of Weiroll for a while, and I was like, well, cool, interesting. You could make another version of Drippie using Weiroll. So what is Weiroll? Weiroll is this like on-chain mini VM on Ethereum. So if you go to, where are my contracts? Contracts, Universal, Drippie v2, Weiroll, right? So here's your VM. Will this be a VOD? Yes, it will be a VOD. I will download it and upload it somewhere else, probably YouTube or something. But okay, so what are we doing? Drippie v2. What is Drippie? Let's just first look at Drippie. Drippie is this contract that that we built to manage on-chain stuff for Optimism. So Drippie is pretty simple. It's got like an interval, and it's got these things called drips, and drips are basically actions that you execute on Ethereum on some regular basis. And so we define this interval, and the interval determines how quickly an action can be executed. So if we set the interval to 1 second, then it can basically be executed every single block. But if we set it to a couple days, we can execute it every couple days. What do we use Drippie for? Drippie is basically the way that we manage balances for different contracts. It's the way that we manage. It's basically, we had this problem that we had balances in lots of different contracts, and just like a lot of on-chain activity that needed to be managed effectively and securely. And so we were like, well, you know, smart contracts manage things securely, so maybe we should just use smart contracts, and we did. So an example of a drip that we might use for Drippie is if the balance of a given account is below a certain amount, we'll trigger a drip to fund that balance. So that's how we maintain balances of various different smart contracts. So yeah, the drip check. Yeah, this whole thing. Yeah, I'm glad you caught that. Yeah, so Drippie it was pretty simple. You have this interval, so that determines how often something can happen. The reason you want an interval at all is because let's say that we're using Drippie to maintain the balance of a smart contract or the balance of an account. If that contract or that account is compromised, we don't want that contract to just be able to send all the money that it has to some other, send it away so that balance goes back below the threshold, trigger the drip again to pull more money out, and then keep this process going over and over again. And so by limiting the drips by adding an interval, we can basically, if something is compromised, let's say we're using an EOA for something, and if the EOA, for whatever reason, is compromised, then we can just detect that. We can stop the drip before another drip goes out. And the worst that we lose is 1 drip's worth of ETH. And that also just means that we can maintain the balance of an account very easily without needing a lot of manual intervention. And so the drip is pretty simple. Like I said, there's the interval, there's this drip check, and the drip check is like it's basically like a smart contract that you call, and it returns a Boolean. So for instance, check balance high. So this is checking is the balance of my account above a certain threshold. Check balance low, same thing, but is it below a certain threshold? Same idea. Blah, blah, blah. So every drip has a drip check. And then it has these check params. So that's kind of inputs to that drip check. So you can see like check balance high has these parameters, target and the threshold. So it's the thing that you're checking and the threshold amount. And finally, it has a series of actions. So the actions could be something like it's a target, it's some data and some value. So that could be, for instance, if the balance of my account is below a certain amount, I'm going to automatically send, or like a transaction will get sent automatically to trigger this drip, send some amount of ETH to the account to keep it topped up. Drippie is pretty cool. It's really simple. And I was messing around yesterday and today with Weiroll to kind of make another version of Drippie, Drippie v2, that's a bit more advanced and that gives you a lot more flexibility with what kind of stuff you can do here. So a couple things I didn't really like about this first version of Drippie was that you can't really manage any kind of state. So interval is like the only state that we enshrine, but there's other stuff that the drip check might want to keep track of. And there's other stuff that even within an action, right? Actions are just target, data, and value. You can't use the result of one action to determine whether you're going to do other actions. So Drippie, basically here, I was coming up with a model, like a very simple model to solve the problem that Optimism had. And then I thought, well, can we make something better just for fun? And I've known about Weiroll for a while, but I haven't really messed around with it. And then I was like, well, maybe we could do something with Weiroll to make this sort of more advanced. So maybe we can store variables within these actions and actually do stuff based on those variables. So back to Weiroll. Weiroll is this simple VM on-chain. And you execute these commands, and you have some state that you maintain. And the commands are basically, it's really, really simple. It's basically just delegate call, static call, or a call with value. And and you can build these commands, and it'll execute, and then you run the execute function, and it's actually going to do these calls for you. And you can also maintain some state, and the results of these calls will get put back into the state. And basically you. It's a cool little way to do like stateful programming on chain. Not a lot of people actually. I don't know who uses this right now, but I figured why not make Optimism one of the first people to make it. I guess maybe you know who I bet uses it. I bet MEV bots use it, but whatever. So how did I start going about this? So I modified the drip config. If you look at the old config, you have the interval, drip check, check params, and actions. And I got rid of all this, and I replaced it with this. I replaced it with basically these are the commands, and these are the state for each of the commands. And this is stuff going into Weiroll. So there's an init script with state. There's a check script with state, and there's an action script with state. And this is pretty cool. So you go down here, you set everything up, right? You store your init script, you store your state, and then you actually run the init script. And this is how Weiroll works. You basically you take the state, and you execute it. And you set the state again. I don't know if there's a better. Oh. Oh, oops, I'm sharing the wrong screen. Oh no, LOL. Okay, one sec, let me change that. Here we go, now that's the right screen. Okay, is that fixed? Are people seeing that? I think it's fixed. Yeah, it's fixed. I think it's fixed. Okay, thank you, sorry. Cool, so like I was saying, the old version of Drippie, I guess I gotta show you this again because I messed that up, had this interval. It had a reference to the drip check for that drip, had parameters for that drip, and it had a list of actions, where actions are a target, data, and value. And that's really, really useful, but it's really simple. Yeah, so it's really simple, right? There's no statefulness. And so Weiroll, you should look it up, Weiroll. And it's this VM, has an execute function, it's got commands, it's got state, and you basically run through each one of the commands. So you're like iterating through the commands, you're figuring out what type it is. So is it a delegate call, a static call, or a call with value? And then for each one of these, the result of the call gets stored in our state. So this gives us a little bit of stateful programming on chain. So it's pretty cool. It's like an embedded virtual, I wouldn't even call it a virtual machine. It's like an interpreter for a very simple script that just executes EVM actions. And so I was like messing around with Drippie, and I was trying to figure out, what do I do with this? How can I make Drippie more interesting? And so I figured, let's do it this way. So this corresponds, I set up a new config. So none of that init here, like I was showing you, putting them side by side. No more interval, drip check, check params, and actions. It's now just these 6 fields. So there's an init script with init state. There's a check script with check state. There's a check, then action script with action state. So you got these 3 stages. Init, that runs once when you create the script. Checks run every time before you actually run the thing. The check has to not revert. If the check doesn't revert, then it'll execute the drip. And then the action script, and that's the final thing to run, and that's going to actually do the things that you want. So going down to the creation function, you can see we're just storing a bunch of state. It's a little, I would say, significantly more expensive to set up. Unfortunately, I think I might be able to not store the init script. I don't think we need to run it more than once, so you can probably get away with not storing the init script. But essentially we have state and we have these 3 scripts. And then the main difference is that we've really simplified Drippie a lot using this mechanism, where you're essentially, if this is the function that checks if something is executable or not. And you actually execute Weiroll, and if this does not revert, then it is executable. That's the idea. You define a script such that if this does not revert, then it is then it's executable, and then you store the state again, and you where are we on the? So finally we get to the drip itself, and the drip is pretty simple, right? You load the drip information by the name, and then we check if the drip is executable. If it's not executable, then we're going to revert, and we're not going to allow this to go. So if your check script came back correct, or came back with the saying you can execute this, then good. And then we're going to go ahead and execute the action script. So we're loading the action state, executing it, and putting it on chain. So this is kind of the easy part, actually. I mean, the nice thing is that this actually significantly reduces complexity on Drippie, which I'm really happy about. Of course, at the cost of shoving complexity into the VM, but you can audit that separately. And you'll notice that I got rid of the stuff like the interval, right? The interval that blocks a drip from executing too quickly. I got rid of that before that was handled explicitly within the Drippie contract here. So like the last time it executed plus the interval less than the timestamp. But now I've just sort of said, whatever, let the user define the interval stuff for themselves. So to do this, I built a nice little configuration scheme that basically compiles into Drippie, or sorry, into Weiroll commands. So here we can see an example script here is example drip for simple balance. And simple balance is just if the balance of my account is less than 1 ether, I'm going to send it 0.001 ether. So you can see the init script. What it does is it's running this one action here, which is you're going to look at the we define this state variable called interval, and we're going to set it to 1. So we're basically setting it the interval at which something can be executed to 1 second. And then where do we use this? Well, if you look at the check script, we have this condition. So if these two things, I use an AND statement here. I'll show you. It's a little funky how Weiroll works. But vm.and, basically it's saying like these two conditions here have to be true. And the first condition is a less than, right? vm.less than. And what is it saying? Less than. So if you add the state, the last time that the thing was executed, plus the interval, actually it should be initializing this up here. This is a good, see, like here's a good lesson. We can change this. So we're initializing the state, the last interval, to 0 at the beginning. And so we've initialized it to 0. And so this is saying if you add the last time it was executed plus the interval, and it's less than the current Ethereum timestamp, so enough time has passed on Ethereum that we're beyond the interval, so we're allowed to execute again. And oops, that should not say gelato balance. That should just say balance. And the balance of my test account is less than 1 ether. If both of these things are true, because there's an AND here, then this is going to return true. So pretty simple, like DSL that I put together just to sort of make the experience of defining and configuring these strips pretty nice, and it's pretty clean. I'm pretty happy with it. And then of course the actions. So what are the actions going to do? Well, it's going to first set the last time that the thing was executed to the current Ethereum timestamp, because we want to make sure that that's updated. And then we transfer 0.001 ether to the test account. Pretty straightforward, kind of. I mean, there's a lot going on in the back end. There's, yeah. So Weiroll is really simple. This is one thing to note. Weiroll is really, really, really simple. And so you have to build a lot of helpers to make Weiroll useful. So I built some basic helpers like assertions. This is just like a simple contract that will assert something being true or assert something being false. There's some coercion between types. There's basic logical comparisons. Or I guess this should really be called logic, but whatever. You've got and, or, less than, greater than, equal to the basics. And you've got some Ethereum utilities, right? Balance, timestamp, transfer. Got some stuff for dealing with Gelato, which is the automation tool that we use. And you've got some math, currently just add because I haven't had a need for subtract yet. And state, which is a simple database on chain where you can maintain state. So all of this comes together, and we have a tool here for compiling this stuff together. So this is just translating this. Where are we? Translating this stuff here, vm.and, and into Weiroll actions under the hood. And then we're compiling that configuration basically into the format that Drippie expects. So you can see down here, if I run my little ASDF script, this is like the low-level compiled sort of bytecode that goes into Weiroll or goes into Drippie and then goes into Weiroll, and that lets you execute stuff on chain. So I think there's a couple bugs right now that I'm going to bang out in a second here, but I deployed a version of this contract on Optimism. Honestly, Optimism is a great testnet because transactions come back so quickly, so I just use it as my primary testnet, the Optimism testnet. So we've got Drippie here. You can follow along. But I can take this data and I can use it and I can plug it into Drippie. But there's a couple of things that I'm noticing as we're going through this, which is that actually right now the state is not shared. And the state should be shared between the different things. So right now the assumption is that there's a single global state. So there's a mistake in the contract where we're separating state for the different things. Right now there's this, you can see there's state I, state C, state A. And as I'm talking this out, I'm realizing that we need to find a way to combine that state into a single global state, which is interesting. Because I don't know how to do that. So let me think about this. This is an interesting problem. So the issue is that each one of these scripts are compiled separately, and the Weiroll planner will generate state for you. What up? E for Exodus, how you doing? So this is Weiroll JS. I think this is built by Nick from ENS. Shout out Nick, thank you. This has been great. And the thing with this is that it currently compiles the script as a single thing, and each script has its own state. But actually, no, I think this is probably fine because we're storing state variables in a separate contract. Yeah, this is okay. The state is just the information that it needs. This is totally fine. I don't know what I'm talking about. This should be fine. So, okay. So it should be fine because the state that we're storing is actually in this external state contract. And the state that Drippie, this state that Drippie is referring to is sort of the internal state of the script while it's executing, which should be fine. So, okay, let me just double check. So, state build, so this is inputs. And it's writing outputs. Where is it writing outputs? It's writing outputs. Yeah, that's fine. So where's the output writing happening? Write outputs, and then there's an index. Yeah, okay, so it's not going to modify things I don't want. We're good. So I believe then the Drippie, the one I've deployed to Kovan, is probably mostly functional. Let me, why don't I share my screen? The other screen, not that screen. Where's my screen, bro? No, that's Twitch. Why? Oh, there it is. Okay, great. So now I'm sharing my. Let me just double check that it's going through. Yep, great. So I'm sharing the Etherscan page. So this is the deployed version of Drippie v2, of course. And I'm going to create a drip here. So I've compiled my simple balance drip. Let's see if the simple balance drip will work. So we're creating a drip, simple balance drip, right? Whatever. And I'm just copy pasting the config that my little script outputted. I'm going to confirm that transaction. So let's see. So this is why Kovan Optimism or Girly Optimism is great as a testnet, because it comes back almost instantly. Great. So we successfully created our drip. Now we need to set the status of this drip to 1, so that's marking it as active. So sending a second transaction here. So let's see, let's make sure that worked. Great. So simple balance drip is now active. And simple balance drip is going to check whether the balance of my other account is below 1 ETH, which it currently is, but let's see. So when we execute simple balance, this executable function, off-chain, it has to be a transaction. So I'm going to send a transaction. So if we view this transaction, hopefully, great. So we get this message back that says drip is executable, but we're reverting for safety. And that's because Weiroll is actually, since you can do calls in Weiroll, we don't want somebody to create a drip by accident that does a call, like a check that happens to do a call to another address that changes state. If unless it's actually being executed as part of a drip, state should never be changed by the drip check. So that's an important feature. So we just revert, but we can see the drip is executable. But now what I'm going to do is I'm going to transfer 1 ETH to my other account. Oops, why is that failing? Transfer 1 ETH. Great. And I've transferred 1 ETH, so now the second time that I run this function, we should get a different error back. So now we've done that. So because that drip, the conditions of that drip, no, there's a bug. So okay, so there's a bug here, or the transfer didn't go through. One of the above. Okay, there's a bug. Or I configured this wrong. Balance of my test account less than 1 ether. Okay, so it looks like there's a bug. I'm going to debug it. Let's find out. So we're going to go to Tenderly. Gotta love Tenderly. Great way to debug stuff. And we're going to see why this drip check did not come back the way that I wanted it to. So if we go to the balance, okay, so you can see it's actually executing all these steps, which I think is really cool, right? It's getting the state, or it's getting this time it's getting the last time that the drip was executed. That's the first thing it's getting. It's converting that to a uint, which is 0. Now it's getting the interval, converting that to a uint. That's the interval is 1 second. And we're going to add that together. That's 1. We're going to get the current timestamp. Is it less than? Yes, it's less than. That's great. So now that's fine. And then finally, oh, I see the bug. I see the bug. Okay, interesting. I made a mistake here. So it is less than, and it's returning true, but it's not doing the assertion on less than. So it's not doing the assert true. And so again here, like you can see balance less than, and it's false. And it's doing the and, but it's not doing the assertion. It's not asserting the result of the call. It's just returning false. So let's go back to the code. Where are we? vm.sol. Yep, that's right. And we're going to... Wait a minute. That's over there. Where are we? Wait, VM... Yes. Okay, great. All right, so this is a pretty simple bug, which is just that in the compiler thing that I'm using, there's one thing missing, which is that the final thing that happens in a check script is that that there should be an assertion that the thing that it's spitting out is either true or false. So luckily we can do this without redeploying the entire thing, which makes me happy. And so the final thing is like I think I can do like let me modify the VM to make this easy. Assert so I'm going to assert that it's true. So I'm adding a command to my VM, which is just a simple assertion, and I'm going to check VM.assert. Great. So now I've added another step to my program, which is actually doing an assertion at the end. Right now it's not doing an assertion. And I'm going to recompile the program. Because I have not added assert down here. Oh man, I need to add assert everywhere. Okay, one sec. Assert. Gotta add it to the program. Just let Copilot do it for me, and then we want to look at the deployments, assert, get that address. Great. So now when we compile this, it should work. Great, we got a good compilation result. I'm going to copy that, and I'm going to switch back to my browser, and I'm going to add simple balance drip 2. So confirm that. I'm going to set the status to active. Great. And now, when I execute executable, we should get an error. If we don't, that's an issue. There we go. So you can see it just failed. It did not, instead of like before where we got this result back where it said drip is executable but we're reverting for safety, this time it just failed, which is a good thing. And if we go back to Tenderly and plug in that transaction hash, you can see now that that we did the and then finally we did an assertion that the thing is true, which makes me happy. It worked. Great. So then, just to make sure one more time, I'm going to transfer that 1 ETH back to the original account. Okay. Great, I've transferred the 1 ETH back to the original account, and now if I... Oh, wait a minute. Let me reconnect. Oh wait, that's the second account. I need to be connected on the first account. One more time, connect. Okay, so simple balance drip 2. If we run this one more time, come on. There we go. Drip is executable, but we are reverting for safety. Fantastic. So looks like it's working. And then to close this out, we can actually execute the drip. So we're going to execute the drip. And there you go. Boom. 0.01 ether to my other account. It works. It works. Okay, great. So now we're going to try one more thing. And we're going to create a third drip where we're going to set a much longer interval. So let's say 60 seconds. Or maybe 120 seconds. And by setting it to 120 seconds, we should only be able to execute it once every 2 minutes. So we're going to recompile. And I'm keeping you on the other screen for a second because this is just going to take a split second. So now we're going to write to the contract. I'm going to create a drip named simple balance drip 3. And install it. Going to mark it as active. Okay, so simple balance drip 3 should be executable now. Let's see it. Great, drip is executable, but we're reverting for safety. And then we're going to execute the drip once. This should work just fine. And if we don't have a bug, let's see. So it executed correctly. Now, if we don't have a bug, we should be able to try to do it again. And hopefully it doesn't do it again, or if it does, and we have a bug. So we'll see. Uh-oh. All right, so there's a bug. Now, what's the bug? Let's find out. Go to the transaction. All right, so we've got, what is the state that we've got? So we've got the, oh, would you look at that? Wait a minute, what is that? Why is that value 0? So let me think about this. Why? So why is that key a 1? That key should not be a 1. I don't think. So there we go. There's some kind of bug here. Let's see it in the, oh, this is the debugger. So we've got the, yeah, so here we go. The key is, it's the value. $78, I bet that's 120, right? Hex to decimal. Yeah. Key. Why is the key being set to 120. There's a bug. Where's the bug? So we're almost done here. Let's find the bug and let's be happy. Let's switch you back to my code. Cool. Where's the bug? So get key. Obviously the key that we're retrieving is wrong. It's the wrong key. So luckily, again, that's just a problem with my compilation. So get state.get hashed should be the hash thing. Interesting. Something very weird going on here. Okay, let me think about this. Where did I mix up the... Let me see my config. My config is set 0 interval.get and last dots. Okay. Oh, wait a minute. This is the beginning. That's the oh, I'm silly. Okay, that's the executable step. Oh, I'm okay. Well, that explains it. Let's go back to here. So wait, no. That's still wrong. That is what I want. Why is it not? Why is the key 1? Oh, it's overwriting my state. It's overwriting my state. Why is it overwriting my state? It's overwriting my state because I guess I told it to. Should not be overwriting my state, to be perfectly honest. I would consider that a bug in the JavaScript library. Why is it doing that? Why is it overwriting my state? Okay, so it's overwriting my state. So we are chilling in here. We did the drip check, the first one. And I did write the state back. Maybe I don't want to write the state back. Yeah, maybe I don't want to write the state back to storage. You know what? I'm gonna make sure that we don't write state back to storage. And by not writing state back to storage, we'll save ourselves some gas, and we'll also just enforce that all of the state is stored in the external contract. So that's not a bad idea. So let's redeploy Drippie. I'm also, in the meantime, I'm going to not store the init script because we don't need to store the init script. It is wasted gas to store the init script. I don't even need to store the init script at all. Okay, so let's not waste any gas. It's frustrating, but what are you going to do? How long have I been writing Solidity? I think since like 2016. So So quite a while at this point. Okay, so we got our new version of Drippie. I'm also going to verify it on Etherscan. Let's do this again. Okay, great, it's verified. I think we're almost done here. So let's switch you back to the browser. And we're going to create a drip. Name it SB1, so I don't have to write that much anymore. Execute. Status SB11. Confirm. Okay. So now, this first execution should work just fine. Great. Come on. Yep. And the second execution, please fail. I think it'll fail. Hey, it failed. Look at that. Okay, great. There we go, Drippie. Cool. So I'm really happy with that. I think now it just needs a lot more testing so that I don't have to do this manually, but doing it manually is more fun. Let's go back. I think this is really cool. I mean, it's nice because it's stateless. Well, stateless in here. It's storing the state in the state contract, which is fine. And yeah, I'm really happy with this. I do wonder. The only thing I don't love is this. So the thing is that the yeah, okay, so I need it to be static. So if I need it to be static, I can either revert or I guess I could revert here, and I could revert with like, I could use like a try catch. I always forget how Solidity's try catch works. And try catch I think works better with custom errors. Custom errors. Is it not? Oh, it's not open. Yeah, I don't love that. Could do a low level call. That's one way to do it. This is just like not super clean. Okay, what's the best way to do this? One option. You could do it by convention, but that's buggy. Oh shoot, it's 6? Woo. I think I gotta get going actually. Okay, I'm gonna think about this. And I'll leave it for next time because it's an interesting problem, but I'm pretty happy with this because it works. So, all right, thanks for tuning in. I have to run to be somewhere at 7. So yeah, thanks. Next time is honestly whenever I decide next time is. I'm trying to do this more often, but I always say that, so I don't know. Maybe like expect like a week or two in between. Gotta drink that seltzer. All right. Yeah, maybe next week, maybe the week after that. But yeah, cool. I sure hope that stream is saved. I should have saved it. I'm gonna make sure this stream is saved right away. I am afraid that it might have not been saved. So, yeah. All right, I'm gonna make sure this stream is definitely saved, and then maybe I can get some kind of software or something that will automatically save my streams, like save automatically, upload Twitch to YouTube. All right, if anyone knows how that works. All right, bye everybody. See you next time. Oh, does OBS record as well? Because I use OBS. I didn't realize you could do... Oh, shoot. I thought you could only do one at a time. Oh my god. Alright, well next time I'm gonna... Yes, thank you. Thank you for doing research. I really appreciate it. No, this is... I feel like an idiot now. I thought that if you clicked start recording that it would shut down the stream and record instead, but okay, next time I will record simulcast. I don't know. That's can you just stream to YouTube at the same time? Yeah, sure. Okay. All right. At least this one I'll just download from Twitch, and then the next one I'll record it and do it manually. Okay. And let me start uploading this. Thank you everybody. Show up. You can come next time. Oh, I never changed the title of this stream. Working on an experimental version of Drippie with Weiroll. Lol. Never updated it. All right. Thank you. Bye. See you guys next time.